On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at two examples of finding limits involving radicals, where we're going to have to use a conjugate in order to actually evaluate the limit. Two examples here. I'm also going to show you right off the bat too, once we start talking about this blue one, how we can use a TI-84 to actually see the limit using the graph or the table, and then I'm actually going to show you how to find this limit algebraically. So for this first example here, if we try to plug in 5 into this thing, the limit as x approaches 5, there's nothing wrong with getting 0 in the numerator. However, notice the bottom, 5 plus 4 is 9, the square root of 9 is 3, minus 3 we get a 0. That's the problem right there. We don't want a 0 in the denominator because we cannot divide by 0. Therefore, one would think the limit does not exist. Well, actually it does. Before we find it algebraically, let me show you a few tips on the TI-84 to help you see that the limit does exist. So I had that same function typed in y equals on a TI-84, and just be careful with your parentheses and your square roots when you type it in. And the first thing I'm going to do with this is I'm going to zoom 6. And we do see a smooth curve, and actually on the color versions of the TI-84, there is an actual hole right there. Some calculators will not show that. But that is happening right there when x is 5. Let's press the trace button, and let's actually move over close to that x value of 5. So as I let x get close to 5, let's focus on what y value it looks like we're getting close to. So right now, x is getting pretty close to 5. Looks like y is getting pretty close to 6, right? And actually, the limit is 6 in this problem. To show you that even further on the TI-84, let's go to our table setup. So let's press second and press window. That's your table setup. Now, table start. If yours does not look like mine, that is totally fine. I'm going to tell my table to start at 5. My delta table, I'm going to leave it at 0.01. If yours says something different, go ahead and type in 0.01. 0.01 is going to allow us to increment x very, very small versus us just going 1, 2, 3, 4, 5. It's going to increment it, think about like a penny. You know, 0.01 is a penny, so it's going to increment it in 0.01 increments. Make sure your pieces here are set to auto. Let's press second and graph to go to our table, and we are starting at 5, and notice we have an error. I'm going to scroll up a little bit on my x's, and notice how the x's are incrementing in 0.01 increments. From the left-hand side of 5, as x gets close to 5 from the left, look at this y value. Getting doggone close to 6, right? Same thing from the right side of 5. As we get closer to 5, from the right-hand side, look at these y values. They are getting close to 6. So, by looking at the TI-84, I'm going to say that this limit's equal to 6. But if you don't have a calculator, how in the heck can we figure this out? This is where using a conjugate can be very helpful. So I'm going to move this red function over to the side. We'll come back and talk about this one in a little while. And let's focus on this function here. So I'm just going to write that down again. And what I want to do with this is we want to what we call rationalize the denominator. Let's get rid of that radical at the bottom and see if anything happens magically where we can somehow plug a 5 into this thing. Because right now we can't. We get 0 when we plug 5 into this. So finding or using the conjugate of the denominator is going to be x plus 4 plus 3. I have two terms down here. I have this radical term and then I have this 3, and I'm simply changing that middle sign in between my two terms. That's the only thing I'm changing there. But we want to multiply the top and the bottom by that conjugate. The reason why we want to do that is because technically what we're multiplying by now is just 1. Whenever you multiply something by 1, you don't change the value of it, so it's totally fine. It's a weird way of looking at 1, but really the same thing over itself is 1. For the numerator, we do have two terms times these two terms, but I'm not going to do anything with those. You'll see why in a second. I'm just going to write them down again. So I have these two pieces. I didn't multiply anything up here, though we could, but that would be unnecessary for this problem because notice the bottom. Let's multiply these two terms here by these two terms here. It's like the FOIL method. The square root of x plus 4 times the square root of x plus 4 is going to be x plus 4. Properties of radicals. Suppose we had the square root of a times the square root of a Kind of like what I have here. Square root of x plus 4 times the square root of x plus 4. That's equal to the square root of a squared. The square root of a squared is a. I think of this as the house burns down. The square root of something times the square root of that same something, I think of it as the house burns down, we're left with what's on the inside of that radical. Now let's take the square root of x plus 4 times this 3. We cannot multiply the 3 by these two pieces because the 3 is not inside of a square root. So therefore we simply have 3 square root x plus 4. Now let's repeat this process for the negative 3. Negative 3 times this, same idea. We cannot multiply that negative 3 by that x plus 4, so we just write it right beside the radical. And now taking the negative 3 times that positive 3, that is negative 9. So we have subtract 9. Growing out my fraction bar a little bit more. Notice we do have some like terms in here. We have some like radicals. Plus 3 square root of x plus 4 minus 3 square root of x plus 4. These two cancel out. Let's combine like terms at the bottom, and really what we have is x plus 4 minus 9 over here. So plus 4 minus 9, we have an x minus 5 in our denominator. And notice at the beginning I said I'm not going to do anything with these because now we have that common factor up there. You notice that? X minus 5 up top times that square root of x plus 4 plus 3. Well, let's cancel these out. We have common factors, canceling those out. Now, what are we doing? Back at the beginning, we were trying to find the limit as x approaches 5. So we can apply that same limit to this, and let's see what our answer is going to be. So now, limit x approaches 5 of just this piece because we canceled out the x minus 5s. And now if we try to directly substitute 5 into here, we shouldn't run into that divide by 0 issue because we don't even have a fraction anymore. So let's plug in 5 plus 4, that's 9. Square root of 9 is 3 plus 3 gives us, bam, 6. The same thing that we had up here. So we looked at the TI-84 for that example to motivate the idea that it was 6, and now we have actually seen how to do this algebraically. Let's do this next example up here in red. To save a little bit of time, you could go type this into the TI-84 and do the table approach or the graphical approach, but now we're going to rationalize the numerator. I'm going to go ahead and jump straight into the algebraic approach to solve this one. So, right off the bat, if we try to plug in 3, 3 minus 3 gives us 0. I don't really care about the top. I know the bottom is messed up, and that's what's causing issues here. But we don't want to use the conjugate of the bottom. We want to use the conjugate of the top. We're going to do what's called rationalizing the numerator instead of the denominator here. So, square root x plus 1. Instead of minus 2, we're going to make it a plus 2. Just like in the previous example, we changed that middle sign between those two terms, putting this at the bottom. And again, we multiply the top and bottom by this same piece because really we're multiplying by 1. All this stuff right here is 1. Now, in the previous example, the top we left alone, but now I'm going to leave the bottom alone. Just going to write it out as these two pieces multiplied together. And again, the reason why I left these two alone, I just wrote them right beside each other here, is because maybe we might get an x minus 3 that cancels out. Let's find out. Let's take our top pieces, these two terms, and these two terms, and let's do the FOIL method, or let's multiply these two binomials together like we did in the previous example. And very similar here, square root of x plus 1 times the square root of x plus 1, the house burns down. Square root of x plus 1 times a positive 2, maybe you're starting to notice a pattern here. This is going to be the positive 2 square root of x plus 1. And then when we turn right back around and take this negative 2 times this radical, we get negative 2 square root of x plus 1. And then last but not least, negative 2 times 2 gives us negative 4. So from here, we can cancel out these like radicals up top, just like we did in the previous example, except those were in the denominator a while ago. Well, now when we combine like terms up top, notice what we get. X plus 1 minus 4, well, positive 1 minus 4, that's going to be a negative 3. Notice that factor pops up at the top and the one we have at the bottom. We're going to be able to cancel those out here. I'm just going to copy everything down. And this factor that we have up here cancels out with this factor at the bottom. Be very careful here. There is still an understood 1 up here. So when all this simplifies, we have 1 over this stuff right here. Now let's not forget what we're really trying to do here. We're trying to find the limit as x approaches 3. So let's apply that limit now and see if it works. So the limit as x approaches 3 of this simplified piece, 1 over the square root of x plus 1 plus 2. Well, we have 1 in our numerator. Plugging in 3 down here, 3 plus 1 gives us 4. The square root of 4 gives us 2. Plus 2, we get 4. So this limit's 1/4. To round out this video, let's go type this one into the TI-84. Let's go look at our table and see if we are approaching 0.25. So since 0.25, is pretty much 1/4, or it is 1/4. So here is that function typed in Y1. I'm not applying the conjugate here. I'm just going to graph this function, watching my parentheses, making sure everything is typed in correctly. And let's just go to our table setup. We could go to the graph here, but I'm going to go straight to my table. Since I'm approaching 3, I'm going to let my table start at 3. I'm going to leave my increment, my delta table at 0.01, and let's jump straight over to our table. So second graph. And notice we do have an error at 3. But like I said a while ago, remember, our limit was 1/4, right? When we did it algebraically. Well, look, as we get close to 3, look at this y value, 0.2505 and 0.2503. Isn't that getting pretty doggone close to 1/4? Because 1/4 is 0.25, and the same thing is happening coming in from the right-hand side of 3 as well. Notice these decimals are getting really, really close to 0.25 as well. And there you have it, 2 examples of dealing with limits that have radicals where we may have to implement the conjugate as we did in both of these examples. One where we rationalize the denominator and another where we rationalize the numerator. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.